All right, so how's it going, everyone? It is Fabrication Friday coming at you from Ascent Fabrication. Joe Fairley here with Mr. Mike Gorski from Filament Innovations. We are taking a look into more so the hardware side, 3D printer side of our digital workflow series the last few weeks. We've been going over 3D scanning, different 3D scanners, going over the software for clinical modifications. We had Mercurus and Spentis on, and now we're getting into some of the hardware, like I've said. So working here with Filament Innovations and Mike to bring high flow 3D printing into Ascent Fabrication. So that was a really awesome addition this week to the printer fleet. We got the Kratos printer from Mike here. We put it to use from day one. Had it going with their PETG for some test sockets, and then had PP Prints polypropylene going through a couple renditions of a socket there that I can happily say came out extremely well. We've got about a 4mm wall thickness here. We take a look at some of the layer lines, came out super well. It's a little bit more flexible than Mike might talk about a little later here, his CPX material. So for some preparatory socket material, dare I say definitive, we'll kind of get into that a little bit later, but everyone pleased to meet Mike here. Mike, you want to take it away with an intro?
Yeah, sure. Thank you for having me. First of all, really excited to be here. It's, love working with someone semi-local, right? We're in Pennsylvania, you're in New York. So, it's always good to link up with local people. But, my name is Mike Gorski, owner and founder of Filament Innovations. Filament Innovations is a family-owned and operated hardware manufacturer of 3D printers. We really pride ourselves on the hand quality work that we do with our machines. Nothing we use here is mass produced. A lot of what we do is right here, American made, American sourced. All of our manufacturing is done right here in Copley, Pennsylvania, right outside of Allentown, Pennsylvania. And if you don't know where Allentown is, it's about an hour or so northwest of Philadelphia. So we'll just say like Philadelphia, larger area of Pennsylvania. Really, our focus is on machines. That's our thing, and innovating niche filaments. So right now with our filaments, we just came out with CPX. CPX is a modified high impact copoly polypropylene. We're using it heavily in the prosthetics field. We're right now getting tested for biocompatibility, for skin safe certified. For what we know, there won't be any issues, but still, let's get those numbers. Let's get that data to verify everything.
For sure.
And as far as the printer side, our focus has been on high flow FDM 3D printing. And right now we're moving into FGF, fused granular fabrication as well. So you're going to see new printers from us coming out, hopefully end of this year, based solely on pellet extrusion as well. So between doing pellet extrusion, high flow FDM, new filaments, and also non-planar 3D printing in the background as well. We've got a lot going on here with our small team. We got a lot of projects happening for the additive manufacturing field.
Nice. A lot of irons in the fire for sure.
Yeah, definitely.
Yeah, let's unpack these couple terms here that we're talking about. So, people know about hobbyist 3D printing through FDM, for years and years now with spooled filament, either 1.75 millimeter or 2.85, quote unquote 3 millimeter filament. So let's talk about first, just, in your own words, what is high flow, and, how did your printers do that?
Yeah, sure. So high flow 3D printing, we define that as any extrusion system that can put out over 2 pounds per hour of filament. Granted, I don't believe there's any standards in using high flow. I mean, you could say a volcano or a super volcano E3D is high flow, right? But for us internally, when we're marketing high flow, we're talking about FDM 3D printing, fused deposition modeling at 2 pounds per hour of a filament-based system. So we were very fortunate to help co-develop the Typhoon with Dice Designs up in Canada. I mean, anyone who's been following us on social media, knows anything about us, knows that we work very closely with Dice Design. And when we heard about the Typhoon, we asked if we could be involved in the beta process. And we went through a lot of beta Typhoons here in our shop, Typhoon being the extrusion system that we use for high flow FDM. And with that being said, we gave a lot of feedback to them during the beta process. We worked very closely with them on that system. And now we are in the production mode of that. So we moved from beta probably 2 years ago, production, maybe over a year ago, possibly. Top of my head, I forget. But we've had the production Typhoons for over a year now. And when we talk about high flow, large nozzles, large volumetric flow, so in a nutshell, 2 pounds of plastic per hour, that's what we can put down, assuming a large flat object. Obviously, if we go horizontal, cooling is an issue. So it comes down maybe about 1 pound per hour. But max flow rate, 2 pounds is what we're looking at. That's how we define high flow.
Okay. So that's a lot of plastic. There's some very intricate engineering that goes on to the extruders for that. So it's definitely a different type of system, right? It's I would say more higher end system. And you definitely get what you pay for when you're talking about 3D printing for industrial uses, right? And for the medical field and prosthetics and orthotics, people have been worried about in the past with the interlayer adhesion, with FDM printing. So, that's something that's always been talked about. But high flow is definitely kind of a newer term, I would think, to some people. So thanks for going over that. Then FGF, you mentioned FGF too.
Yep. So FGF, fused granular fabrication. So that's instead of using filament, we actually use the material filament's made out of, which is pellets. Then we actually will bring the pellets into a pellet extruder with a mixing screw that will go ahead and it'll actually mix all the pellets together, melt it, and deposit it. So we're still early on, I'll say, in our FGF initiative. We use the Pulsar from Dice Design for that. We've been building the machines for over a year now, but we're just starting to learn more about FGF, what pellets, developing profiles, drying levels for the pellets. So even though we've been building machines for a year, we're just really heavily getting into the science now, so we can actually have our own documentation to support our customers with.
Awesome. Yeah, and then so with that fused granular fabrication, that would even be more typically used for larger items, right?
I would say larger, right? It absolutely could be used for the prosthetics industry for sockets. It's mainly used for larger automotive fixtures, large art pieces, large jigs. We're talking massive objects, like say you want to print a kayak, right? That's where FGF comes into play.
Sure.
That's where I personally love the Typhoon high flow system, because you're getting a little bit of both, right? So with pellet systems, you can put roughly 3 to 7 pounds per hour, depending on the plastic being used. But with our filament system, the Typhoon, you're putting out 2 pounds per hour. But it's a nice middle ground between high-end pellet output and a standard hot end. So a standard hot end doesn't put out much plastic at all, maybe 100 grams per hour, I believe was the number that I saw, 100 grams per hour. Where the Typhoon is this nice middle ground area. Plus, you can put a 2.5 nozzle on it and do a 1 millimeter layer height and a 4 millimeter wide pass at a roughly 25 millimeters per second. So we're looking at roughly an inch per second doing a large layer line, large pass, but you still get the benefits of being able to use a standard slicer, to use retraction, use pressure advance. And it's much easier for customers to jump into because they're already used to filament-based systems. We're just melting more plastic and depositing faster than anyone else can.
Right. So to give people an idea, this socket right here was printed in just under 2 hours. So that really starts to compete with traditional fabrication methods in prosthetics and orthotics. When we're talking about 2 hours or less to have a preparatory socket, that person could come by in the morning, get 3D scanned. They do the clinical modifications on software. You have it printed, and by the afternoon, your patient's walking out the door, with a preparatory socket. So, we're starting to get down to some, much quicker lead times, which is really, really nice. Again, 2 hours for the print at the 2.5 millimeter nozzle at 1 millimeter, layer thickness. That's the layer thickness to me is one thing that we're going to be kind of testing internally here at Ascent Fabrication, where we want to make sure that the friction, in between, those different layer heights, whether or not it's really going to make that much of a difference in our clinical applications. Does it affect how the patient's going into the socket? So we'll get back to you guys with some of our findings from that. But just to give you an idea of what can be printed like that. before I forget here, we're just going to turn off the video now to kind of give us a little bit more bandwidth, and I'm going to show off, Mike's website here, as well as give you guys some screenshots of the 3D printer here at Ascent Fab, the Kratos, and then a couple more of the prints in process. So we'll go ahead and turn off the cameras there, and I'll show you guys his website. Yeah. All right. So so Mike, we're on your website. I'm just going to go into first the Icarus page and give them a little view of that. If you want to talk about, we'll talk about the Icarus and some of its features.
Absolutely. So our Icarus is definitely the bread and butter of Filament Innovations. That's the machine that we've been coming out with a new generation every year. A new generation meaning smaller upgrades, nothing crazy, but we understand that in this, it's a tech industry, right? So we have to innovate and we have to come out with new stuff. But at the same time, we also allow backwards compatible customers to upgrade anything we're coming out with. So we want to make sure we don't leave any customers behind, but we also want to be innovative in our offerings. And our newest Icarus comes standard with the production Typhoon unit. So that's what you're seeing there on the website. You're seeing the Typhoon, you're seeing the water cooler that's on the back, or on the inside, the bottom of the unit. We offering everything comes plug and play, everything comes pre-tuned. You're getting powder coated PEI plates, actually. So that's 1/4 inch mix 6 aluminum that's actually powder coated with a soft PEI powder coat. It's a smooth texture. I believe, from what I know, we are the first company to be using this type of powder coated PEI build plates. So with build plates, it's really hard. Some people like flexible build plates. Some people like adhesive based build plates. I personally like powder coat. The reason for that being, me just as an automotive junkie, I know that powder coat holds up. You can take a knife to it. You're not going to scratch it. It's not going to be some sticker that's going to break on you, which commonly happens with adhesive back systems. So we actually were able to source a manufacturer for a certain type of PEI powder, which has smooth finish, which can be powder coated. So we're really happy to include that stock on all of our Icarus units. Closed loop linear motion on the X and Y axis. You don't have to worry about any loss of steps, so you're getting high accuracy. But one of the biggest things that differentiates us, besides the PEI plate and the Typhoon and all that, is the ball screws. So we're one of the few companies I know that's using fully enclosed ball screws on a 3D printer. And we use those ball screws because we're just not a fan of belt-based systems. Belt stretch, they break, they have to be retensioned.
Oh, sure.
The ball screws are just done. That's it. Keep them greased, keep the ball screws greased, keep the rails oiled. It only takes a few minutes every month to do that, but you're not tinkering. We don't want our customers to tinker. Like that's the thing. That's why we created Filament Innovations. We don't want the tinkering on the customer side. Not saying that as a hobbyist, don't get me wrong. Like, they can get in, they can have fun, but when you're buying one of our machines, our job is to make sure it's working for you, because we're looking at this as companies are buying these machines as capital assets, right? They're buying these machines because they want to use them to save on labor costs and to make money with. And so when you buy from us, you're trusting us to deliver that to you, right? So any problems, any concerns you have, it's our job to make sure your machine's working and you're fully trained on how to use it. Because these machines are $31,000. So when they land at your doorstep, you're going to be eager to plug it in and get going with it. So that's why they all come pre-built, pre-tuned. Plug it in, level the bed out. Takes about 5-10 minutes. Get it on Wi-Fi, load some filament, get your first slice going, and you're good to go.
Right. Yeah, and that's exactly my process. As soon as I got that Kratos in the door and unpacked, it was extremely plug and play from the get-go, and just a little bit of back and forth between Mike and I, but we had that thing printing within the first hour that I turned it on, really.
Yeah.
And yeah, I mean, it's a really, really nice system. You'll see a couple pictures of it here, and maybe a couple videos of the first couple prints that I've done, and some pictures of those prints of a below the knee prosthesis or prosthetic socket rather. but definitely plug and play. I've used, quite a few hobbyist machines in the last 7 years that I've been 3D printing. And honestly, as we get into these more industrial applications, people don't want to be plugging and playing, or I'm sorry, they want to be plugging and playing. They don't want to be tinkering, like you said, where, they're going to have to really get into the mechanics of the printer itself, right?
Right.
Then you have to have an engineer on staff, or someone who is very well versed with 3D printing, that they know how to fix the machine after something breaks, or after they see a failed print.
Right, exactly. And that's one of the things that we pride ourselves on is our level of customer service because, God forbid if you have any problems, and then I get it, stuff happens, right? We always shoot, for our customers have no problems, but something happens during shipping, anything comes up, we want you to know that we have your back because you're trusting us to build and manufacture and deliver to you a plug and play machine and make sure it's highly reliable. So any questions, concerns, you call us. And one of the benefits of working with us is you can talk to the direct technician that built your machine. You can call and I can answer. I'm the owner of the company and I'll give you a straight answer on how we fix it, how we move forward. Honestly, customer service is probably our best thing because I get it. If I buy a machine, we're a small business.
Yeah.
If I'm putting my money into something, I want it to work, right? I mean, it makes sense. Time is money. And when these businesses are buying these machines from us, they know time is money. Right. So the less they need to have an engineer or a technician tinker on it, or why isn't this working, or why isn't that working? Sure, we cost a little bit more, and I understand that, but the machine's going to pay itself back because it's going to keep running, it's going to keep working, and that's what we put. I think what our brand and our name shows, like these things are made to work. So if they don't work, we're going to fix it and we're going to get it right immediately.
Right. And I can't stress that enough, to my customers and, just the feedback for you guys. Like the customer service here at Filament Innovations is awesome. These guys definitely know what they're talking about. And, you don't have to hesitate to reach out to them because you'll get an immediate response. If you get a Creality printer, you're not going to be getting customer support. It's just not going to happen. So, there's definitely a level of, that hobbyist tinkering going on in the field right now, which is great for some things, right? I'm pushing some people to, if they truly want to learn 3D printing and they want to do that on the lowest budget possible, sure. If you want to go out and get a hobbyist level printer for under $500, go for it. You'll definitely learn a heck of a lot about how to 3D print and how to fix a 3D printer by doing that. But for some of these clinicians that I'm working with, obviously they don't have that time, or they don't want to take any time away from their clinical experiences to stop working with patients and having to work on a machine. So I can't stress that enough. Again, you're purchasing not just the printer, but the overall customer experience as a whole, and then the level of knowledge these guys have in 3D printing, and making sure that these printers are going to last you years, and they're going to update as the years go on. So
sure, absolutely. And the one thing for us is accountability, and I tell my guys all the time, accountability. So if you have an issue, we're accountable. We don't pass the buck onto somebody else. We don't give you some, this happened. No. If something happens, we are accountable. So it's kind of like the old saying, the buck stops here, right? So you have an issue, we fix it. And I tell people who are kind of on the fence, I'm like, go find another manufacturer that you can call and talk to the direct tech or the owner of the company that either built your machine, or the owner of the company is going to stand by. You don't have to go through levels of customer service. Well, we'll see this. We'll get back to you in 48 hours. I mean, we're a small operation. That's not how we run our business. You have a problem, we fix it because we know time is money. And if that machine's not running for you, it's not doing what you wanted to do, it's not the reason you bought it from us. You bought it from us, it's supposed to run, it's supposed to work. And that's what we stand by.
Right. Well, I mean, that's definitely the experience that I've had so far, and I can't wait to explore some of these more research and development opportunities with you.
Awesome, definitely. I'm looking forward to it.
Yeah, for sure, man. We're on the Poseidon page now, and this thing not only looks like a beast, but it looks like someone's entire room.
Yeah, I was
could
told I
take
was
up.
told it could be it's probably the size of some New York City apartments is what I've been told by a few people.
No, that's about a $1,200 a month, studio apartment right there.
Yeah, yeah.
Yeah, tell us a little bit more about, kind of what spurred that project. Because I remember, following you guys early on, and just it was a custom build originally, right?
Right, right. So initially, about actually this time last year, we had the Kraken Project for Atomic Props and Effects, which was a 4 by 8 foot build area of a 3D printer. So it was a beast. I mean, four
Yeah,
by 8 by 4 feet build area. I mean, good lord, the machine almost took up one whole section of our shop just
yeah,
building it. And then after we shipped it, we said, we have a lot of this work done already. Granted, a lot of people don't need a machine that large, but how do we scale it down, make it easier for the customer to use? Trying to run a 4 by 8 foot by 4 foot machine is a beast in itself. You almost need two
oh
people to
yeah,
get that thing operational, just because of the size of it alone.
right,
But let's scale it down. Most people at the time loved having a 1 cubic meter build area. Okay, great. Where that standard came from, I have no idea. But we saw 1 cubic meter being thrown around a lot. We know just from our own experience, people like having a larger x-axis in the worlds of manufacturing.
yeah,
So we sat down and we said, hey, let's do a 1400 by 1000 millimeter build area of a machine, based on all the work we did on the Kraken. But let's make it let's go one step further, and let's actually include pellet extrusion as well, which
right,
is kind of so now when we're selling our second generation Poseidons, we're giving manufacturers pellet and high flow on the same machine, which is kind of new. I know there's other companies out there that have done it on as well, but I think it's new in the sense where it's not just a pellet, it's not just a filament based system. You can still have a large scale machine and do small accurate prints with a filament based system, or just press a button and automatically switch over to the pellet system. And all of a sudden now you're using a 5 millimeter wide nozzle, right? Gigantic, putting
yeah,
down 5 pounds of plastic per hour and just, tearing through large layer lines, large layer height prints, just getting it done. So we kind of have one machine for larger base manufacturers. I want one machine that can do filament or pellet and a turnkey package.
yeah. No, this is definitely a more all-in-one solution for a lot of different applications, right? So,
Yeah.
from different applications, we're in the prosthetics and orthotics field, but Ascent Fabrication is definitely open to working with other fields. So, if you're out there and you want to print something on one of Mike's printers, we're more than happy to do any kind of sample prints for you, and see how we can get you into production. But let's talk a little bit more about, what different industries, you've seen applications in for your printers.
Sure. So I can tell you our printers are involved in the automotive industry. They are involved in the sporting goods manufacturing industry. So our printers are also out there. Our Icarus units are in government and defense, U.S. Army, Navy as well. We have a first generation Poseidon with Dias Design Pro Series system down at the Naval Academy in Maryland. So we definitely don't just do prosthetics. We're heavily in manufacturing and heavily into the automotive scenes. But for us, it's feel good about the prosthetics, right? It's that was kind of what helped put us on the map with the high flow system, where we can do prosthetics, in 1 to 2 hours. And so that's really what helped shine light onto high flow filament, high flow prosthetic sockets, and kind of helped push FI more into the spotlight. I'll say, like, wow, these guys have found a really great case study and they found a great application for additive manufacturing. And I think that's where people are still, I hate to say this, but I think it's just true, right? People are trying to find a use case for additive manufacturing besides just prototyping.
Sure.
And I'm hoping our research with CPX and our research we did with Dias Design on the Typhoon,
Yeah.
we can help get to and use prosthetic sockets using our technology. I mean, that's our goal. Are we there now? I think we're pretty darn close.
Oh yeah.
I don't want to shoot myself in the foot until I'm a man of I'm from the field of analytics, right? I like numbers.
Yeah.
I don't like nonsense. I don't like marketing buzzwords. I hate all that. Anyone that's ever met me, I'll tell you that right now. If I can't back it up with numbers, I'm not going down that road.
Right.
But we are darn close to getting this done through FDM technology and our CPX material. I'm hoping we can get to definitive prosthetic, definitive below the knee prosthetics through our high flow printing, our CPX. I'm hoping we're close. We're darn close. So I just want to get some numbers to back up our statements and go from there.
Well, that's just it. We got to have those peer-reviewed journal articles that got to make their way out there and, provide some of these, long-term cyclic data, going through the standard 10.3.28 cyclic testing. That would really be a really neat, research study that I know that some people are looking into right now and might even be in the process of doing. But yeah, that's another call out there for any researchers or people looking to, get into that space with us. I would be more than happy to, get involved with that. I'm a research buff. I've written papers myself. I've been published. I'm definitely on that side of, having that, that clinical data, be supported by, scientific data and numbers. So it's only going to help us moving forward in the prosthetic and orthotic fields, with outcome measures. And, it's going to be really cool to see that develop, internally and externally here in the field. So,
and that's the thing. To me, it's all about data and numbers. And so we have some, research and some tests we've done now on patients wearing sockets, and so far everything has been turning out great. And so I think we're ready to move forward now and actually get some numbers behind our sockets and see how we do.
Yeah, definitely. I've got some numbers, but we'll be increasing our numbers here pretty soon, and going to be using the CPX, and possibly some polypropylene to try out these preparatory sockets and definitive. Traditionally, we talk about a preparatory socket being used for, anywhere from like 1 month to 6 months, possibly longer than that, up to a year. But for something to truly be, quote unquote, definitive, if it's going to be able to pass a 3 million cycle test under ISO 10328, that is absolutely termed definitive. That's what our prosthetic feet go through right now for that cyclic testing. So, we have to kind of, come up with these standards because historically our field really hasn't had these standards. We haven't done enough testing with laminated sockets with carbon fiber, to know that it lasts 3 million cycles, because every single one is custom and everyone makes them differently. So, moving forward, I think that's going to be a really great step for the prosthetic and orthotic field, and, not only help, the field of additive manufacturing and its use case for, P&O field. So, we appreciate the level of collaboration, you guys are interested in with us.
Yeah, absolutely. And I think that's what's going to help move this industry forward. Because I mean, to me, like I said, I'm a numbers guy. I'm a quantitative person. So I want to make sure our products live up to the data requirement and exceed that requirement as well. So for me right now, what we're seeing is, imagine, our end term goal is to print a definitive socket, right? That's the goal. So as soon as we can, define what defines that from a numerical standpoint, then we can move forward and see what we can do on the 3D printing side. But, say we accomplish all that, just taking, a step back here and looking at the larger picture, if we can use our technology and use a certain grade polymer to 3D print definitive sockets in 2 hours, like, to me, I'm not a prosthetics expert by any means, but I think that sounds revolutionary, right? I mean, imagine what that would do for developing countries where maybe you don't have access to the level of medical care we're fortunate to have here in the United States. I mean, good Lord, trying to take systems like these down and making sockets in 1 to 2 hours, I think that would really be revolutionary. I mean, like I said, I'm not an expert, but I would think it is, right?
Yeah, no, definitely. I mean, I've had experience in Haiti, in Port-au-Prince, over the course of a year and a half. I went down there with a few different individuals. We were doing some nonprofit work with 3D printing. We actually brought 6 3D printers from Ultimaker down there.
Okay.
And we were doing some initial, evaluations of upper limb prosthetics because they weren't weight bearing. We felt a little bit better about trying to apply that in this, developing country where, we were actually training the Haitian prosthetists how to 3D scan, how to do the clinical modifications, and how to 3D print and fit, the devices that we were coming up with. That was in conjunction with one of our partners as well, the Victoria Hand Project from Canada.
Okay.
And it was a great success. There's still 3D printing devices today, and they still have ongoing collaboration efforts between Victoria Hand Project, myself, and a couple other individuals. And it's definitely a different tool for them to use to hopefully have easier access to quality devices. There's still a lot of hurdles that we'd have to get over, but with the biggest problem down there in Haiti, a lot of these materials are hydroscopic, right? They're going to be soaking up soaking up water from the air, and trying to dry out filament just isn't going to happen in those environments.
Yep.
So with a material like polypropylene and/or copoly, I'm not sure if you could speak to CPX and what the hydroscopic properties of that are.
It is not hygroscopic, I can tell you that, and that's what you're discussing is one of the reasons why we chose polypropylene.
Yeah.
It's because we took a step back and try to look at the larger picture of what we're trying to accomplish and saying, let's choose a material that's already been used in the field, like copoly polypropylene. To what I've been told has been used in the prosthetics industry for a while. And how can we also curtail our choice of material to move forward with that benefits the 3D printing industry, such as storage and usability. And that's where, one of the reasons why we chose polypropylene, not only because it's already been used in your industry, because it's not hygroscopic. Right. So that way, if you're taking this material, to a different country where the conditions aren't the greatest, you don't have to worry necessarily about moisture because it's not going to absorb it. So what you're mentioning is one of the kind of questions we asked ourselves before we went down this route, and we chose the family of polymer because we want to make sure we have something that's easy to use, easy to store, and it's reliable. Well, we're trying to find a golden goose or a unicorn, right? We're trying to find a unicorn here. And I know it's really hard, and I know people think we're crazy, but we're trying to find the right material that answers the processes questions, answers the 3D printing questions for the users who are operating the machines. We're trying to find that material that suits all the parties. So we're really looking for a unicorn. I'm not saying CPX is a unicorn, but we're trying like hell to make it a unicorn.
Yeah, no, definitely. I mean, it's a great, initial step again toward this research and development of, new and innovative materials and processes by which we're making, prosthetics and orthotics. Again, the biggest hurdles that we saw to, just being able to print down there is also then just the shipping. How do we get this material reliably? Not only on like a regular basis and as cheaply as possible, but reliable in the sense that it actually makes it there when we think it's going to get there.
Right.
Do we have to talk to higher levels of government in order to create these shipping routes that are reliable? And again, in a developing country, that's definitely on the very short list of things that they're going to be paying attention to. But it's one hurdle that we're trying to look at right now and trying to get with some different partners to make that a little bit easier, because at the end of the day, we can just pack a bunch of this stuff in our suitcases and bring it down there. We can definitely do that, but how sustainable over time is that? So the few partners we're involved with, again, we're still going through the processes of how do we get the materials there to them once we have a printer there, which is a whole separate shipping issue. If we're going to be getting something as huge as an Icarus down there, I'm sure that's going to be a hurdle also, but this definitely has those applications.
Yeah, Yeah, and that's what we're trying to do. We're trying to accomplish it. I mean, someone's got to try, right? So we're gonna try. Hopefully we accomplish our goal here. You know, we can materialize what you and I are talking about. We're hoping Filament Innovations can be that spearhead that, you know, figures it out. Maybe we will, maybe we won't, but we're gonna go down trying, right? You know, I mean, we're gonna keep
Yeah.
going until we exhaust all options, but we're gonna try.
Right, right. No, I mean it's a really cool niche area that I would be very thrilled to go down that route with you guys and
Yeah.
any other interested
Well,
parties that are listening to this.
you're a part of it now, part of the ship, part of the crew, right? That's what I've been
Yeah,
told.
that's it. That's it. Let's go
No.
for it because it takes a little ambition to make things happen, right? So
Yeah.
yeah, we'll definitely go down that route. But yeah, in terms of again other maybe applications or further use cases for your systems, you mentioned non-planar 3D printing, which I
Yeah.
am hugely interested in and fascinated by. So could you speak to that a little bit?
So we are literally just jumping into it. Dye's Design came out with a non-planar heater core for the Typhoon that, believe it or not, it's actually plug and play right into the system. So I got to give them props for making sure everything they come out with is compatible with the Typhoon high flow system. So right now we're hoping by the end of the year. I don't want to jump the gun here, but we are actively using a non-planar slicer right now to start figuring out what do we need to do to make our production Typhoon Icarus units non-planar backwards compatible. So from a technical standpoint, replacing the Typhoon heater core is easy. It's plug and play, you put it on, that's not hard. But bed leveling and cooling are the two issues we have to work on in-house here, and that's what we're currently working with. And then how do we also go about making sure that this is easy for the customer to do in terms of doing the cooling, doing the Z offset, the guides are written, the profiles are dialed in, stuff like that. So our two immediate materials we'll be working with for non-planar would be CPX and PETG. Those are kind of our two staple materials that we sell in the prosthetics industry.
Okay.
But we're hoping to have a turnkey package by the end of the year, because as soon as you go to non-planar 3D printing, it really opens it up for, I'll say, new designs, possibly even better strength of sockets.
Oh yeah.
So me as a researcher and analytical guy, granted I don't have the evidence right now, but I would imagine if instead of printing horizontal lines and now we're adding some type of curvature to the lines of the socket of the Z-axis, I would imagine there's going to be an impact there on strength. Will it make it stronger? Will it make it weaker? Until we do the test, I don't know. My personal guess would be it's actually going to make it stronger because the forces are going to be distributed differently. Instead of evenly over a flat plane, the forces are going to be distributed over a different type of design with the prints and the lines not being completely flat. So I would imagine we should be able to even make stronger sockets with CPX. And we actually just found out this morning CPX can be annealed as well. So we're like, okay, so now we just threw annealing into the picture, and now we're throwing non-planar into the picture. And the information we have already, I'll say the more quote unquote street science from our early adopters of CPX, that's working great for preparatory sockets as is.
Yeah.
So now if we throw non-planar and annealing into the mix as well, I mean, do we even need an additive in CPX to get to a definitive grade socket? I don't know. Maybe just annealing it and doing a non-planar print will get there. I mean, I'm asking these questions not as a business owner, but as a researcher. Like, where do we need to go to get to that point? But we just threw two more variables in the mix, and those variables highly likely will lead to increased strength in the final product. So we'll find out. We might be closer to a definitive socket than we think. I don't know. I'm not saying that as a researcher. Maybe we are, but we have two new variables which could immediately get us there. I hope, from a personal standpoint, I hope so. But we're gonna figure that out. But yeah, you can expect non-planar from us sooner than you think.
That's awesome. Awesome to hear. It'll be cool to be a part of that with you if we're able to go down that route together. And definitely has applications for prosthetics and orthotics. I mean, being able to print something, at the speed that you're printing at and have the trim lines already cut out as well.
Yeah.
We're printing primarily in vase mode for, the fast printing process that we're using. So whether or not vase mode exactly works the same as, the same slicing steps for non-planar, if non-planar would end up being a little bit faster, a little bit slower, that'll be interesting to check out as well. Having the
Yep.
trim lines printed into a socket and or an orthosis would be interesting. Those strength properties, absolutely. I mean, I've got a physics background, and I'd have to think that
Yeah.
optimizing the forces at which are going parallel and perpendicular to the layer lines, I mean, has to be a key, innovative way to make these stronger. So, again, primarily sockets, definitive sockets have been made out of, continuous carbon fiber. Um, if we're able to then print a CPX, shell, and then possibly even print another material over the top of that,
Yeah.
those are some other applications that I've thought about in the past, to even further increase the strength of a socket like that. Would be really, really neat to check all that out. But
Yeah.
there's a lot of possibilities here. I love the level of innovation that you guys are doing. I mean, heck, it's right in your name, right? Filament
That's right.
innovations.
If we're not doing it, we're not living up to our name, right? And we want to be, true to our mission statement, true to the customer. We want to support USA manufacturing. If we got to do that, we got to innovate and stay on our toes.
Right, right. Well, I know we've got some, fun times ahead of us, and I appreciate you taking the time here today to introduce Filament Innovations and the printers that you have, the materials and research and development you're into. Definitely, everyone listening to this, check out, what we're doing at Ascent Fab to help further that research and development with these guys. Again, if you're outside the prosthetics and orthotics field, don't hesitate to reach out as well. Because we can definitely support those services. We're going to be helping out Mike here with the clinical side of things,
Yep.
having some, clinical support initially with, what should you be printing in prosthetics and orthotics with their machines, how to get up and running in-house with their machines, doing some, troubleshooting and support. Mike talked about that, customer support. So we're going to be helping those guys out with that as well. And yeah, the future is bright, my friend.
Absolutely, man. I'm happy to be working with you. I'm looking forward to seeing what we can do together. I know CPX, non-planar, now with anything we just discovered as of this morning.
Yeah.
It's there's going to be a lot of fun things the next few months. You're going to see us. We got a lot on our plate, but I'm very fortunate that the FI staff is full of a lot of very bright people, very hardworking, passionate people. I'm very fortunate for the team that we have here. It takes all of us to come together, and us being a small family-owned company, we have a lot of passion and a lot of drive. So if we're going to innovate and make some strides in this field, hopefully people keep their eyes on us because we're moving pretty fast.
Absolutely, man. I couldn't agree more. Well, yeah.
Awesome.
Thanks again. Anything else you wanted to finish up today with?
No, I mean, thank you so much for having us. Special thanks, definitely Dye's Design for putting up with me and Film Innovations and all of our antics to make the Typhoon better and just keep pushing it. And yeah, I mean, we've made a lot of friends in this industry, and especially our customers, because really, if it wasn't for our customers, we wouldn't be here. We're a private, we're self-funded. I mean, we don't have any grants, we don't have any corporate, any large parent company funding us. It's us. And so if there's no one else really. So if we rely on our customers and our own innovation. So honestly, thank you to our customers the most, because if they weren't buying our machines and our material, we wouldn't be in business. So thank you. Very, very simple business model, right? So thank you to our customers.
Right. No, that's exactly it. I think that, if I can just touch on that for a minute as well, Ascent Fab is in the same exact spot, right? Currently, I am Ascent Fab with one other, CAD designer that helps me out from time to time. But Again, all self-funded. We share a lot of the same values here with Mike and these guys at FI. So we're right there with them. And as a American-made startup, I think that that culture kind of gets muddled a little bit, and people might even look down on you if you're not in the founder space of trying to go for all this money from these angel investors or VCs, where it's becoming quite popular now for just any new company to seek that out right away.
Yeah.
But I greatly appreciate that you guys are kind of on the same wavelength with us right now on that, and
Sure. Yeah.
it's a fun space to be in.
Well, I think too, and I might, people might disagree with me on this, but that's fine. From a business ownership, I believe once you get VC funding for growth, so and I get why people do that from a business standpoint,
Yeah.
but I think you become detached from the company. It's easier to pass the blame onto somebody else. You're hiring more people. There's more processes, and I get that, but it's hard for accountability, right? And that's where I'm going with this. I'm going with accountability, and that's
Right.
where us here at FI, if there's a mistake, we are accountable. That's why I talked about earlier in the podcast here, is that you call us if there's a mistake. We don't say we have to investigate this. We have to get back to department A,
Right.
B, C, D, 1, 2, 3, whatever made a mistake. We made the mistake. We control the mistake. We man up to the mistake. We fix the mistake, and that's kind of how we run our business here. And I believe when you grow and get large and take on the seed money for growth, that becomes detached. It's much easier to
Sure.
pass the buck and pass the blame onto somebody else.
Yeah, yeah. No, I couldn't agree more. Again, we share a lot of the same thinking in that respect. And obviously there's a place and time for funding for certain companies and certain
Sure.
fields, I definitely get that. I'm not, poo-pooing the
No, no, no,
the
no, no,
funding
neither am
industry
I.
at all.
Everyone's
But
company is
yeah,
different, but I love the business model of, hey, you can call the company that built your machine and
heck
talk
yeah.
directly to the technician that worked on. I mean, good luck if you buy a Creality, right, an Ender 3. Good luck trying to
Yeah,
find the technician that built that machine.
right.
That's what makes us unique, where people put their faith in us to deliver a product that's turnkey, that's worked, yada yada. We talked about it. And I want to make sure our brand, we live up to that. I want to make sure that that's very important to me, to make sure our brand is respectable. People look at us and they put their trust in us, and that's why we're here.
Right. Yeah. I couldn't agree more. Couldn't agree more. But yeah, thanks again for going through everything here with us today. This was a
Thank you.
great introduction to high flow 3D printing. We covered a lot of ground here on the hardware side of things with Mike, and we're going to be continuing to explore the different options with Mike and his team, and other 3D printing applications with different materials. So stay tuned. A lot of exciting and fun things to happen. Thanks again, everyone, for watching. This is Fabrication Friday. Joe signing out. Have a great weekend.
Thank you.